Hi everybody. In this video, I'm going to cover a few odds and ends that I think we need to cover before I start talking about how we use Postgres with JavaScript. Here I'm in Cloud9 again. Again, you can use any development environment you want. I really like using my Mac now, but I thought I'd just try something different with this video. Let me expand my terminal here. And as you know, when we created this virtual machine, we created the Node one. So let me just check out the version of Node, and it's 4.7.3. And I really like using Node 8. In fact, for what we're doing in the class, it's sort of required. So let me go ahead and install that as the first thing we're doing. If you're installing Node on the Mac or Windows, chances are good you already have 8. Okay, let me just stare at this a second to make sure I have it right. Looks good, I guess. And what this is doing, it's downloading the Node package so then we could locally, so then we can install it. Okay, and it tells us what we need to do here. We need to do sudo apt-get install node.js because it says as root here, so I'm putting sudo in front of this, as you probably learned in other classes. And just to check that we have that installed, I'm going to go Node.js version. That's 8.21, fantastic. The previous one we used was Node. And the difference is, so there's one instance of Node that's called Node and one that's Node.js. On Mac and Windows, at least I know on Mac, it's called Node. On Linux machines, there is already a program called Node. I think it has to do with packet radio or something like that. So most Linux installs use Node.js. I see this one here in Cloud9 uses Node, but that's sort of unusual with Linux. So now, though, we do have one that's 8.21. So that looks good. So let me go ahead and create a new file here. Let's just run stuff from a file. And in this file, I'm just going to have one line to start. This is going to be a JavaScript file. I'm going to go set timeout. It's set timeout waits a certain amount. It's sort of like a wait in other languages. So I'm writing a function here. The function only does one thing. It's going to print out goodbye. So that's ending the console log line. That's ending the function. And now I say how long to wait, and I'll say 2 seconds. So what this is going to do, it waits 2 seconds, and then it executes this function, and this function executes it prints a line out to our screen that just says goodbye. So let me go ahead and save that. I'll call it try.js. You can see that it got saved over here. Oops, that was not the place to highlight. And if I do an ls here, you'll see try there as well. All right, so let me execute it. Node.js, try.js. So we're waiting 2 seconds, and it prints goodbye. So not all that exciting, and it's probably what we expected. Let me add a few more lines to this code. I'll do a print here, a console.log. Hello. Let's just say hello 1. I'll just say hello again. Let me revise I always don't know what to print when I'm doing these little demos. Okay, I think this looks good. Let me just look. All right. So now the question is, well, what does it print now? And I'll just pause a second for you to figure out what order things get printed in. Okay, and let's see what actually does happen here. So let me execute that code. So it maybe goes against what you think should happen. Maybe some of you thought it should print hello, then wait 2 seconds and print goodbye, and then print hello again. But instead it said hello, hello again, goodbye. And what this set timeout function does is it sets a timer, and after 2 seconds this function will get executed, but it doesn't pause our execution. So once it sets that timer and gets that function queued up, it executes the next line in our code. And this highlights the difference between things that are synchronous, which means that if we have line 1 and the next line, line 2, that we know that line 2 will be executed after line 1. It's sort of waiting in line. When there's one person at a ticket stand to get some ticket for some ride or something, if someone's ahead of you, that person has L1, they're going to get their ticket before you get your ticket. So it's kind of processing through a queue one by one. The other option is asynchronous. And that means, let me just copy this code here, or copy the comments. And with asynchronous code, we don't know. So maybe L2 gets executed after L1, but L2 may be executed before L1, as this example showed, even though here we have line 2, that goodbye got printed after line 3. And so this would be like you go to a restaurant, and you get, there's some people in line, your turn comes, you're the group L1, and then a moment later some other group comes, L2. The waiter comes up and says, what do you want? And you order. And that doesn't mean that they wait and ask the next group, L2, what they want after you get your meal and stuff. You're kind of promised that you're going to get your meal. We got what you want, and they can keep going. So things aren't held up in waiting just because, you're in the process of being served. Things can happen at the same time or look like they're happening at the same time. One waiter can service a number of tables rather than wait on one table before completely wait until the whole meal's finished before another thing happens. And maybe you're thinking, well, why would we ever want to do this? This doesn't seem like anything that we ever did in, well, maybe you did in 220 or 240 or other classes, I'm not sure. But I can give you some compelling reasons, I think. So consider that I'm sitting here in New Mexico, southern New Mexico, with my laptop, and I'm communicating with the server in California. Now, that communication occurs quite quickly, but it's not super duper fast. I mean, if I make a request to that server in California, maybe my program could do some odds and ends, other things, while waiting for a response instead of just waiting and doing nothing. So even though things look quick or seem to operate quickly, there's still some waiting involved when my program could be doing other things. And it's the same even when when our program is waiting we make a request to a database server, and we're waiting for a response from that database server. That response happens pretty quickly, but it's not this super duper quick. So while we're waiting, maybe our program can do other stuff. So there's some motivation for doing things asynchronously. Now let me show you another example, and before I do that, this one's going to involve a database. I'm going to kind of ignore all the databasey stuff in this example and talk about it in the next video, but it's a way of illustrating why this is sort of an interesting problem. And let me go ahead and do that. I think I have my Finder thing here, and I have some code here. Let me just show you that before I upload it. I have this Billboard SQL file I made, so it's a database Billboard. I have a little table which has the current hot songs right now. They obviously have changed since or when you're watching this, but right now that's what's hot, although some of these have been around for a while. So that file is sitting on my laptop here somewhere, there it is, Billboard SQL. And Cloud9 lets me just kind of drag, and I'm going to just put it there. All right, so now I have that file there. Let me just make sure it's there. And let me make this big again. Okay, I have Billboard SQL, and let me load that in. I think you remember how we did that. So I have to go into PSQL minus U for user, Postgres. Now I'm going to read that file in, Billboard. Okay, and let me just do that select. Okay, looks good. Oh, I shouldn't have got out, because the next thing I want to do is make a user for that Postgres can be using. All right. Okay, so I'm going to create a user. I'll call this user Music Manager. Okay, grant select on Hot 100 to, oops. Okay, and now I'm going to set a password for Music Manager. And let me say this, if I'm just putzing around on my laptop or just experimenting, I'd be tempted to make a password like XYZ123, or maybe I'll call my password or things like that, which is very convenient. But the hassle is that you'll get used to doing that, or you may forget, and then when you actually deliver a product, you'll have a really bad password. And just to illustrate how bad it is, so I'm going to the site here, how secure is my password? Let me get back to nothing. And let me type in the word password. To guess the word password would take 1 minute 13 seconds, so a program wouldn't take very long to figure out that. Let's try XYZ123. That's less than 1 second. Let's try Music Manager. That's a little harder, so it says. So what I do, because I'm not really good at coming up with fancy passwords on my own to remember it, I just have a program that generates passwords. And I'm going to generate a password here. I'm using LastPass. And that one, when I say how long it'll take, it's 36,537 years. So that's a pretty long time. So even though it's sort of a hassle to use these passwords, it's good practice. It's helping you not forget. So it'd be really tragic for you to get hacked just because you forgot and had a password called password. And I've had lots of experience with developing kind of specialized research sites for various groups before I got this job here. And even rinky-dink sites that I thought, who in their right mind would want to hack? There's a lot of people out there who are just trying to hack stuff, and they would try to attack my sites, even though I thought, there's no really reason why they would want to hack it. One danger might be this: if you still say, well, who cares if people hack my site? Let's say you have a login feature of your site. You let people log in to do various things. Well, they might use their login information, their password, on other sites like Capital One, some banking site, and Bank of America. So you releasing it, you may think, well, that's not a big deal. Who cares? But to these people who don't use good password management, your release of data on your rinky-dink site may really have important ramifications to them. So really be careful when you're demoing stuff to somebody here on campus, some group asks you to do something, make sure you use good password and good security. So anyway, I'm going to go ahead and use that password that got put up there. And let me just actually save that before I paste it in here. I'll just make another comment and put it in. All right, I think it's that one. So password is not password. I'm setting a password for Music Manager. Enter the password. Let's see if I can just paste it in. It looks good. All right, so that's looking good. So now I have a user with a really good secure password that's going to take pretty much forever to break into. And let me upload another program just so I don't have to type it, and I'm not going to explain much of the program. I'm delaying that for the next video, but I have a JavaScript program here I want to do. All right, and let me quit onto this. And let's see if I have that JavaScript program. I do. There it is. Okay. So now what I'm going to do is I don't have any connector. And again, I'm going to explain this in more detail in the next video. I don't have a connector for Postgres. So what I'm going to do is kind of make a directory for my project. I'm going to call it server demo. Okay. And then I'm going to move my billboard.js file to the server demo. Now I'll change the directory to server demo. All right. So what I'm going to do is this npm init. So right now, let me back up. So right now, the only thing I have in there is billboard JavaScript or a JS file. So I'm going to do npm init. And this asks me a series of questions. Well, for demo programs, I generally skip all this information. So name server demo, sure, why not? Oh, I can't contain, well, then I'll just go server demo. Version, looks good. Description, don't need one. Entry point, I'm not going to have that file, but I don't care. Test command, don't need it. Git repository, don't have one. Keywords, nope. Author, don't bother. License, no. And everything looks good, so I'm going to type yes. What happens here is it creates this file, package.json, and what that allows us to do is when we install stuff, these various packages, these libraries that we need, and let's say now we give this program, we wrote this program, we give it to someone else, this package.json contains information about what packages we installed. So this is really handy if we want to distribute this to someone else. So what I'm going to do is install the Postgres little package. All right, so I'm good to go. So let me open that server demo.js file. And let me make sure I have this copied. Sorry, phasing out the billboard.js file. Okay, and that password's this. And I think it was called Music Manager. We'll find out shortly. And this wasn't Workshop. This database was Billboard. All right, so we're going to ignore all this stuff. I'll talk about it later. And we'll ignore this stuff because I'll talk about it later. I'm interested in these two things. Oh, that's true. It's not defined. All right, I'm interested in these two lines. So what this line does, line 12 here, is it's going to query the database server, and with this query, select everything from hot 100. And then the next line is it's going to log that response. So if I didn't make any errors, let me save this file. And now I'm going to run it, node.js, billboard.js. And I sort of am hanging here. But let's see what happens. So what printed was this promise. There, it finally got some information. So it printed promise pending. So it didn't fail, but it didn't print the response I got from the query, because what this query returned was sort of like the waiter when you place an order. The waiter kind of promises to bring you the food. He doesn't bring it immediately. And it's sort of the same thing with many programs or many functions in JavaScript, that it's just a promise that I'll get the value to you someday. So promises are objects that represent values that will exist in the future. So this, when we get this result back, this printout, it just says, you know, sometime, I was going to say someday, but it's faster than that. Sometime in the future, I'll get the results for you. These will be the results. So that's the idea with promises, that it's making a promise that it'll get those results to you in the future. So one method of using these promises is described in depth or explained in depth on the React video. So I'm not going to cover it. And that one is the one that uses these .then approaches. So after the promise returns, then do whatever the then says. And you could package these up in kind of combination. And as I said, they're covered in the React video, so I'm not going to talk about those at all. But what I will cover is another method, which I think maybe is a tad easier. So in the class, you'll be dealing with both these, the real type promises, and this other one. So let me show you how that works. So I think I'll start changing this code around here. So in JavaScript, there's a function called, or you can define functions that are asynchronous with this way. You can say async get hits, let's say. So I'm going to get these hits. Well, I got this response here. Let me just copy that out, stick it in here. And what I can do is, before this query, I'm going to put the word await. So what this means is async says, hey, this function can be executed along with other functions. This await says, wait until this line is done, this pool query part is done, before executing any other lines in this function. So so await has to be inside a function that has this async word. And let me just, now that okay, and let me, so I'm calling this function. It's an asynchronous function. It's going to execute this line. It's going to wait until the, Postgres gives back the information. Then that information is stored in response, and I'm going to just print out to the console or here the rows of that. So what doesn't it like here? Get hits is not defined. Okay, I don't know why that's saying that. All right, let's give this a try to see if this works. Okay, and it did work. So let me make this bigger. So here you get the first, it's printing funny because some things require more room than others, but you get all the entries here in this JSON. Well, it's an array of JSON objects, right? So we have this one going from here to here. This is rank 1 with the title and artist. Here's the next one, rank 2, and so on. So we get the results. So this is what we want to use and what we really have to use when we're using Postgres and when we're doing other things in JavaScript as well. So the idea is, whoops, sorry, wrong place. The idea is that we need to execute things asynchronously. There are several ways to do it. One is to use that promise and .then that's covered in all the React videos, and another is just to use these async and await. And the await means we wait on this line here before executing these other lines, as opposed to that first try method. I think I lost it. Here it is. You know, it didn't wait. As soon as this function got or made a promise, it executed this next line. So that's it. That was a few odds and ends I wanted to cover before diving in depth into Postgres. Hope this was helpful. Take care.